Okay, this is some more work from section 4.3. This is number 5 on the homework problems. And we have this function y equals x times the square root of 8 minus x squared. And first of all, we want to check the domain because we've got the square root. And remember, we know that the 8 minus x squared, okay, the radicand must be greater than or equal to 0. It can't be negative. And that's going to give us our domain. We add x squared to both sides. And then take the square root of x squared, which is the absolute value of x, less than or equal to the square root of 8. So actually this is our domain. It's going to be all the values between and including negative the square root of 8 and the square root of 8. So that's our domain. So we have a closed interval, so it's going to be easy to find our absolute extreme as well as our relative. Well, first of all, we'll find the relative. And we'll take the derivative to find our critical values. And again, we're just going to use the product rule. First times the derivative of the second. The second is going to be 1 over 2 times the square root of 8 minus x squared times the derivative of negative 8 squared, which is going to be, negative x squared, which is going to be negative 2x, plus the second, which is this the square root of 8 minus x squared times the derivative of the first x, which is 1. So that's our product rule. Then we can simplify this. The 2's cancel. And x times x is x squared, so I've got negative x squared. And we want to get a common denominator so we can make one fraction. It'll be a little bit easier to find our critical numbers if we've got one rational expression. So I'll multiply the top and the bottom by the square root of 8 minus x squared so I can get a common denominator of that. I've already got it in the left term, so we'll try to get it in the right term. Okay? And then we do that. This is my negative x squared, and then if I multiply the square root of 8 minus x squared times the square root of 8 minus x squared, I just get 8 minus x squared. All over the common denominator of the square root of 8 minus x squared. And then these combine, so I've got 8 minus 2x squared over the square root of 8 minus x squared. And if I look for my critical points, which are going to be in the interior, where the denominator is 0, that's when my derivative will be undefined. When the numerator is 0, that's when it's also going to be undefined. That's when it's going to be, well, that's a critical point. So either the first derivative is 0 or the first derivative is undefined. This means the numerator is 0. This means the denominator is 0. Or the denominator 0 would imply that. So if I set this denominator equal to 0, that's going to be 8 minus x squared equals 0. 8 equals x squared. Or it equals plus or minus the square root of 8. And those are the endpoints. So those aren't critical values. Those are the endpoints. But keep that in mind. And then if we look at the numerator, when the numerator is 0, that's going to be 8 minus 2x squared equals 0, 2x squared equals 8, x squared equals 4, x equals plus or minus 2. All right, so those are my critical numbers, or the values that give me my critical points. I'll put these into the original function. So here's the original function. And I've got y of negative 2 equals negative 2 times 8 minus and then negative 2 squared. So this is the original function. I'm putting this in the original function. All right, so I have negative 2 and then negative 2 squared is 4. So negative 2 times 2 is negative 4. And then y of 2 times 8 minus 2 squared, positive 2 is going to be just a positive 8 minus 2 is going to be also 2, so I'm going to have, in this case, negative 2 times 2 is negative 4, 2 times 2 is 4. So these are the values I get. So my points are going to be negative 2, negative 4, and 2, 4. Okay, to check those critical points. So let's take a look at my first derivative test over here. Now I know the function is undefined. So let's take a look at the line here. There's kind of a lot to this problem, so there's a lot to write down. So here we go. I think we're okay here. All right. Okay. So I put this is basically what's happening. Remember, at these endpoints, the function is undefined to the left or to the right of these endpoints. All right, this is the domain. So the domain is just from -8, the square root, negative the square root of 8, to the square root of 8. That's the domain. So we're just dealing with the function in this domain. And these are the critical points, or the x values for the critical points, -2 and 2. And we found over here by putting the function, those values in the function, those points were actually -2, -4, and 2, 4. So let's see what happens if I put -2, or I could have put I put -2.5. I could have put a -3 in there. If I put that into the derivative, so I'll go back and look at the derivative over here. Okay. If we put 3 in here, 3 squared is 9, this is definitely going to be negative. And also, well, negative, if I put 3 or -3 in here, it's going to be the same thing, so it's definitely going to be negative. And then if I put 0 in here, it'll be positive, because it just depends on the numerator. Remember, the denominator always has to be positive. Can't be negative. Can't even be 0. So it always has to be positive. So that's what we're talking about. Okay, it will be 0 at the endpoints, but that's not where we're dealing with, because your critical points are in the interior, not the endpoints of a closed interval. So we just have to worry about the sign of the top. So again, if this is going to be bigger than 2 or smaller than -2, this will be bigger than 8, so this is going to be negative. And if this is equal to 0, which is a good checkpoint, it's going to be positive. So this is how I got my values, by putting those values into the derivative. So here we go. So let's get this ready to go here. All right. So this is negative, positive, negative. So since the derivative is negative, my function is decreasing. It's positive, my function is increasing. It's negative, my function is decreasing. So it looks like I got have a relative minimum here and a relative maximum there. So we can say that the point -2, -4, we found that over here, is a relative minimum because y prime changes from negative to positive there. The point 24, we found over here, 24. Okay, the point 24 is a relative maximum. Why? Because f prime changes from positive to negative there. And again, increasing, decreasing. Okay. Now we also can look at our endpoints. Okay. So this is something else we have to check. And this is going to be significant in this problem. Hope you can read all this stuff. It's kind of small there. We're running out of room. Okay, the square root of 8, 0, this is the right endpoint, is an endpoint, it's a right endpoint, and a relative minimum because f prime of x is less than or equal to 0. It's negative for all x in this this half interval, half open, closed interval, to the square root of 8. So in this interval here, the derivative is negative. Since this is a right endpoint, all right, it's going to be a relative minimum. Why? Well, because the function, since the derivative is negative, it's descending down to it. So it's going down to it. So that means it's going to be the low part of the descent, since it's the right endpoint. Okay, negative the square root of 8, 0, that's a left endpoint. It's a relative maximum because, again, f prime is f prime is less than 0. That means the function is decreasing, but it's descending down from it because it's the left endpoint. So the function is decreasing from it. All right, so it's going to be a relative maximum. So in each case, the derivative is negative. The function is descending, but since it's descending down to this one, it's going to be a relative minimum. Since it's descending down from this one, it's going to be a relative maximum. Okay. All right, so we've got the 4 possibilities for the absolute extreme, and we just have to check those, and then this is going to be actually the absolute minimum. So -2, -4 is actually also an absolute minimum, and 2, 4 is an absolute maximum because we have a closed interval. And if you graphed it, it would look something like this. It would be real easy to see it. This was our 2, 4. If this was 4, -4, and this was 4, and this is 2, and this is -2, and this is your endpoint. It goes something like this. It comes down to here, goes through 0. You can check and find that 0 is on the graph. When x is 0, it's 0. It looks something like this. And it's just that's all there is, because it's just defined on that domain. So if you can see that, let's put that down just a little bit for you here. So that's basically what the function looks like. There's your absolute minimum, there's your absolute maximum. Relative minimum, relative maximum, and there's your left endpoint, which is a relative maximum, and your right endpoint, which is a relative minimum. Okay? So I hope that makes sense.